Welcome back to the next video. In this video I will show you how to rotate and scale a 3D model with help of orbital controls in Angular and Three.js. So firstly I will show you guys the output. So here I have one cube, and if I move my mouse over the cube I am able to move it, rotate it, as well as if I touch my mouse, like drag it, I am able to scale it as well. So yeah, that's what we will be looking into in this video. So first I have created an AngularJS project. Then you will have to go to, so if you see my package.json, I have installed two dependencies. One is this 3 which comes from ThreeJS, so npm install 3, and here I have also installed the types as well. So in case if the types are not automatically installed for you, do make sure you install the types inside dev dependencies as well. Next, inside app component.html I have just taken a canvas and I have just add this identifier of my canvas to our canvas element. Next, if you go to app component.html, given that I am using Angular 17 and I have enabled server side rendering, that's why I have to use something like this. So firstly I'm getting my canvas with the help of the identifier of my canvas. So I'm using @vuechild. I'm getting our canvas. I have kept the static as false, and here I'm getting the element ref for our canvas, which will be helpful later on, so that we can get hold of our particular canvas element. That's what I have done over here. And make sure you add all this imports, particular imports. This is from 3. And for orbit controls, currently I had to use this 3 example GSM controls, orbit controls, but the Three.js documentation suggests that you should import it from over here. But at least at the time of recording it is causing me lot of issues, because this 3 add-ons is still a little bit experimental and it might cause some issues. Like when I was using it with nextjs, which is a React framework, it worked for me, but for Angular I'm still facing some issues. That's why I have to use this older way of importing orbit controls. But first check if this is working for you, then don't use this. And inside our constructor, after next render, we are first getting hold of our canvas element, okay, using this, and then we set some size, so inner width and inner height, whatever is of window is. Then we create a scene, and then we create a box geometry. Later on we create a mesh basic material. Here you can pass whatever color you feel like. Then with the help of geometry and material we create a mesh, and then we add it to our scene. Then we create a perspective camera, so I have just passed this particular values and aspect ratio, and you don't need these values, but if you want you can pass it. And then we add our camera to our scene, and I make sure the camera is looking at the mesh dot position. Next, I have created our orbit control. So this is the important part. So the orbit controls require cameras as well as canvas, and I have enabled the damping equal to true. Next, we have created a WebGL renderer and we have passed our canvas to it. Then we are setting the size for our renderer by passing the width and height. And here we have created a clock. Previously in last video I was just rotating this mesh, but here I have just stopped it because we are using orbital control, so you can rotate it by your mouse as well. Also we don't require this and we don't require this as well, so if you want you can just comment this part as well. And here we are inside the tick function is called every frames per second, so we are calling it inside windows.request animation frame, and for the very first time we are calling it manually. And here we are just rendering our scene and camera by passing scene and camera. This is necessary because the orbit controls require it. So once you rotate or scale, this needs to be updated. That's why we are using this. So if I move it, as you can see it is working. If I scale it, zoom in or zoom out, it is working as well. So yeah, that's it. Thank you for watching. Bye.